We were welcoming everybody to joining us today. For you on the East Coast, a good afternoon. We just slipped into afternoon. And for those on the West Coast, good morning. We're so glad you're here with us today. I am Stacy, Miss Stacy. I am the Senior Director of Programs for EarthEcho International. And I am so thrilled today because I have a science assistant. This is Miss Vivi Rose. And she's getting ready to go with her protective eyewear since we're going to do some science today. We were giving people just a second to log on and solve any technical issues. We had some technical issues, but we're going to get started in just a second.
In the meantime, Mom, what do you do when no one laughs at your chemistry jokes? I'm this joke again.
So what do you do when nobody laughs at your chemistry jokes? I don't know, Vivi Rose.
You keep telling them until you get a reaction.
Ah, nice one. We like that joke. That's a good joke.
It's a really good one.
Yeah. So, guys, we know that everybody, it feels like everybody in the world is getting online right now and trying to do Zoom meetings and Google meetings and lots of different things. So if you're having problems with your internet or if you're having problems with the signal, please, you guys, just be patient. Make sure that your internet connection is good. And if it's not, please know we're going to record this. We're going to put it on our YouTube page and you can watch it later if you need to. Be sure to subscribe. And so when this is recorded, there'll be a subscribe button. Be sure to subscribe so that whenever we do videos like this, you'll get a notification and you'll know what we're doing. So for those of you who may not have done a YouTube live event before, depending upon what kind of device you're on, if you have it full screen, you may not be able to see the chat, and that's okay. But if you want to see the chat, either adjust your tablet or change your computer settings a little bit, and the chat will be either on the side of the video screen or below the video screen, depending upon how big that window is. And we are ready to answer your questions. We'd love to say hello, talk to you guys. Want to give a shout out to some of our friends out there. We know Ava and Eden and some awesome folks at Harborview Elementary School are tuning in today. So, hey guys.
I hope Amelia's here.
And Amelia too. Hope Amelia's here. So, what do you think, Vivi Rose? Should we get started?
Let's get started with Fabulous Fun with pH.
All right, awesome. So let's quickly go through what people are going to need today, okay? So first thing we're going to need are some jars or glasses or something like that to do the experiment, right? All right, and then we're also going to need some measuring cups and spoons. And we're going to note, everybody, that we're using today, we're going to use English units because we're doing kind of some kitchen science today. But you know, if you were in the lab, then we definitely go measure. All right. And you'll also need a sieve and a bowl.
Right here.
There we go. And water, which we have kind of under the table. We'll pull that up in just a second. We've got a whole bunch of water. And then you'll need some red cabbage, which we have this right here. And we took about a third of a red cabbage and we put it in our blender. And we blended it up with about a cup of water. So we've got kind of a slurry of red cabbage here. So that's step one. So if there are any parents or adults that are helping us out with our science kitchen today and you guys want to follow along, go ahead and cut up about a third of this and mix it up in the blender and get yourself a little slurry with about a cup of water. Now, the other thing that you can do, if you don't have a blender or food processor or anything like that, takes a little longer,
box grater.
Right? Say it again.
Box grater.
You can use a box grater. So if you grate up the cabbage using the box grater into a bowl and then a cup of water, then you'll be good to go. You'll have that same kind of slurry. So you should be great if that's what you're going to do. Now, we've also got a few different things. Here, hand me that, Vivi Rose. And why don't you show them some of the stuff we have over there that's off the camera.
So we have some lemon juice, some hand soap, some ammonia.
So these are all just things you can find around the house, right?
I forgot what this was.
You forgot what that was? That's just a clear soda.
Oh, clear soda. We have
some laundry detergent.
Borax.
Yeah.
And we have.
You don't have to pick them all. We've also got what?
We have bleach. We have dish soap. We have vinegar, and we have baking soda, and we have some different
fertilizer type of stuff that we've been putting in some water. So so that it could dissolve a little bit. So those are the things, and you can use any stuff around the house that you want to use. So we've picked up the things that we already had around the house because
food and chemicals.
We're all staying home these days. So this gives us a chance to check some things out. So if you got a chance to join us on Wednesday, Casey did an amazing snack size science on Wednesday about pH. So we've got a little bit of information about pH already. We wanted to explore it just a little bit more with you guys. So what is pH? So pH it's a chemical property of solution. So all of these different liquids that we talked to you guys about, they have properties. They have physical properties. What are some physical properties? Yeah, what state of matter they're in, liquid, solid, hardness is a property, physical property, things like that. But chemical properties are properties that that happen to a material when they're subjected to some sort of different action or different kind of conditions. So with pH, it has to do with how things are in a liquid state, how they dissolve in water, and what happens in that type of dissolving in water. So another type of chemical property would be flammability or how things burn. That would be a type of chemical property too. So, but pH is something, yes, like that. So pH is something that we measure, and we actually use pH as a measure of health for our water bodies in our EarthEcho Water Challenge. So if you haven't checked out the EarthEcho Water Challenge, then you should check that out too. But pH is a scale. So we assign numbers to different materials like ammonia and bleach and lemon juice, but we assign a number between, what do you remember? 0
and 14.
0 and 14, exactly. So between 0 and 14. And right in the middle, what number's right in the middle of 0 and 14? 7. So 7 is our neutral pH, right?
7 is our diver, and there's
a diver?
pool.
So 7 is our neutral pH. Then we've got below that, the 0 to 6, we've got acidic conditions. And then above that, we've got what we call basic conditions. So it's basically how much acidity is in something, or how much basic, which is the opposite of the acid. So how little acidity is in something. So that is what pH is. And Vivi Rose, I wanted to let you know Nathan says hi. So give a shout out to Nathan out there.
Hi, Nathan.
One thing when we talk about pH, it's kind of like, who really cares? We know that water is neutral, but all of our bodies and animals' bodies and stuff in plants, it's all made up of different solutions. Okay, so what's an important solution in our bodies, Baby Rose? Blood is a really important solution in our bodies. But so you guys kind of understand pH. Water is neutral. So 7 pure water is neutral at a 7 pH. But our blood actually runs just a little bit basic, a tiny bit basic. And our blood runs about a pH of 7.4. So that doesn't seem like much different than water, right? And we know that our bodies are made of a lot of water.
Yes.
So 7.4 and 7.0 that's not really different, is it? It is. You're right, it is. So it's really different. As a matter of fact, if your blood's pH goes down to like 7.3, then you can be put in a state called acidosis. And acidosis is something that can make you really, really sick and in some cases can even cause death and permanent damage to your body. So understand that the scale from 0 to 14 is a different kind of scale. So it's called a logarithmic scale. Can you say that?
Logarithmic scale.
Logarithmic scale. And so the logarithmic scale is a factor of 10 each time you go up one number. So going from 7 to 8, it's 10 times higher pH from 7 to 8. So that's how pH works. And it's important that we understand that even small changes in pH can cause big changes in biology and in ecosystems. And so can you hand me that water challenge kit? So when we use our EarthEcho Water Challenge kits to test pH, we use these awesome little tablets that show us the pH indicator. So these little guys, we put the water in the tubes and then we put a couple of these tablets in there and shake it up and it gives us a color change. And we can tell what pH we've got based on that color change. So today, since we know that not everybody has an awesome EarthEcho Water Challenge kit, we're going to make our own pH indicator using just stuff that's from around the house. Okay? So what we're going to do is use red cabbage, because red cabbage is a fantastic plant that has an indicator built into it. So what we're going to do is check out how red cabbage can be used as that indicator. So let's go ahead and get started with the science. Do we want to do that?
Let's get started with fabulous fun with pH.
With pH. All right, so we're going to make our own indicator. So we know that water has a pH of 7. It's our neutral, right? So why don't we put a half of water in each one of these jars, Vivi Rose? Okay.
That's heavy.
Yeah, it is heavy. So we got our water right here. So you're going to put the water in. Okay. Tell me when, because we want them all to be equal, right?
That's half cup.
Okay. So we're trying to get everything equal so we can test, make sure that all of our test parameters are the same. Did you have it turned the wrong way? There we go. Got it?
That's good.
Okay. Also, you guys may see we've got a little pro tip here for you guys. This is a puppy. Yeah, that's a puppy pad down on the table. So if you're doing some science that might get a little wet or might get a little splashy, grab a little puppy pad if you have one and put it down on your table, and it'll protect everything that's underneath and soak up some of those little spills. So pro kitchen science tip from Miss Stacy and Miss Vivi Rose. Got it? All right, let's start with those 4. Okay. So the other thing we need, so we've got our water, which is our solvent, because we're going to make solutions. So, but what we need is our indicator, right? So here's our indicator. And you can see we got the very juicy cabbage. And when you do this, folks, when you do this at home, I know you guys don't have smell-o-vision, but it's a very distinct smell.
It's gross.
The red cabbage. So that's a fun thing too, to stink up your whole kitchen doing science. We do that from time to time, don't we?
It smells gross.
All right, so we've got plenty. I think that's plenty of indicator, don't you think?
Oh yeah, that's plenty.
All right, so why don't we go ahead and put a little bit of indicator, maybe 1 tablespoon of indicator in each one of our, here you go. Got it? Okay. So as Viv is putting the indicators in there, we're going to, just so you know, if you don't have a sieve to get your cabbage juice out, you can also just use a coffee filter. So if you want to just put some of that really, really wet slurry of cabbage into a coffee filter and then just squeeze it out, you can get your indicator as well. So that's another way you may be able to do that. So we've got 1 tablespoon of indicator in each one of our jars here. I'm going to move our awesome EarthEcho Water Challenge kit so we can see right here. So we're doing lemon juice. Viv wants to do lemon juice first. So we're going to keep 1 as our neutral pH, right? So we're going to do 1 is going to be our water. Okay, we'll sit it right there. All right, so let's make an observation. What color is our indicator when the pH is neutral?
Purple.
Purple. Now Viv would leave them all purple. She would totally leave them all purple. So, okay, go ahead. You want to get a stir? So we did forget a stir, so we forgot one thing, but all of them are purple, and that's when things are neutral. Now, if things are acidic, a lot of people have done these experiments in the past. So under acidic conditions, this indicator will turn either light pink or even red if it's a strong acid. Neutral is purple. Put in a tablespoon of lemon juice. So let's let everybody see the magic, okay? I'm gonna put it right here. Let's put it right here. Okay, got it? Just put it in there. So we're gonna do a tablespoon of lemon juice. Okay, while she's doing this, does anybody want to make a prediction? Do we think we'll see pink? If it's a base, hold on. If it's a base, then it will turn this blue color. If it's a weak base, if it's a really strong base, it'll turn a greenish or a teal color. anybody want to make a prediction? Let's give them a minute. Do we think pink? Do we think blue? Do we think teal for lemon juice? What do you think?
Let's see.
All right, let's check it out. Did anybody guess pink?
Because I did.
If you did, you're winning. Good job. All right, let's check out something else. What do you want to check out next? Do you want to check out the let's do the
Oh, what about the bleach?
let's do the detergent. Let's do the laundry detergent.
This one?
Yep.
One in the box.
Yeah. Let's try that. Okay. You got a tablespoon?
Oh, yeah.
All right, it's okay. It's okay. I got a towel over here. All right. Kitchen science. Good times. All right. Fabulous fun with pH. Let's make some predictions. She's getting it out here. So we've got an acid with our lemon juice. What do we think is going to happen? Let's put it right here. What do we think is going to happen? What do you think is going to happen when we put a tablespoon of laundry detergent?
I don't know.
Eden, was that pink? Was that pink for lemon juice or was that pink for laundry detergent? I see Eden's out there watching.
Hi, Eden.
Oh, Eden said pink on the lemon juice. You were right, Eden. All right. What do you think for the laundry detergent, Viv?
Maybe purple, teal.
Teal? You think teal? So you think it's a strong base. All right, let's see what we got. All right, you gonna stir?
Jeez, it's not changing color.
It's not changing color. What's going on?
Oh, I think you gotta stir it a little.
You gotta stir it a little bit?
Oh, it turned a darker purple.
So it's turning a little bit of a different purple, yeah?
It's I guess it's a weaker base.
Weak base, maybe? It definitely didn't turn pink. Or do we think it's pink? I don't know. Not pink.
Compare the two.
This camera's on, babe, right here.
Pink, dark purple.
And then that
is regular purple.
is the regular purple. So let's let it sit. Let's let it sit for a minute and see what happens. Why don't we try? Does anybody else have an idea? Does anybody else? Green, Eden, I think you're getting close. I think we'll see this one react a little bit as we do the rest of them. Why don't we try? What do you think? Baking soda, maybe?
Oh yeah.
All right. You try the baking soda. I'm going to get us another one ready to go.
Can we check for predictions first before I add?
Sure. Does anybody have a prediction about baking soda? Just give it a second. It takes a second. Do we have a baking soda prediction out there? What do you think, Viv?
I think it's gonna be blue.
You think blue?
I think so.
So you think this is a base as well?
I think so.
All right, we'll give it a shot. All right.
And I was right.
Give it a stir. Blue, so we got blue. So baking soda is a little bit of a weak base, right?
Right.
So a little bit of a weak base there with the baking soda.
Are there any guesses now?
And I think everybody's there a little bit later. Why don't we do one more thing? So we've got blue right here. What
Blue,
else?
Purple, pink.
What else should we test? Does anybody want to? We'll test two more. You guys tell us in the audience. We've got ammonia. We've got soda. We've got dish soap. We've got vinegar. We've got bleach. Eden called for blue on the baking soda. High five, Eden. Good job. So what do you want to do next, Phoebe Rose? Do we want to do?
I think I want to save the bleach for last.
Okay. Well, we're gonna do two more. So
we haven't tried the soda yet.
Well, we might try that later. Okay. Let's go ahead and do the ones that we know because we had to run a little bit late because we had the tech difficulties, and I want to make sure that we wrap up by 12:30 and that we answer all the questions. Okay.
Ammonia.
So you want to try ammonia?
Mm-hmm.
Oh nope, somebody else said soda, so I'm gonna have to go with soda. Well, we can do ammonia and soda. We can do ammonia and soda.
Ammonia first, then
Okay.
soda.
All right. Well, I'll just pour the soda directly in here. All right, here comes the ammonia.
Oops.
So we went a little over on that one, but that's
Oops.
okay.
I went a little over.
It's
but
kitchen
it's
science.
green.
It's all right. So
It's green.
what do we know about the green? Is that a weak or a strong base?
It's like a really strong base.
That's a strong base, and you can smell it too. Can you hand me the soda, please? You don't want to ever do that. When you smell things in science, you waft it towards you, okay? You waft it towards you. You don't take a big whiff of it.
That was, yeah.
So can you hand me the soda?
Yeah.
All right. So let's do the last one. We'll put a half a cup of soda.
Ooh, it's bubbling. I think
Yeah.
that's good, Mama.
What do we think? Do we think acid, base, or neutral, everybody?
Hem.
You gonna put it in there? You're just gonna put the indicator in this time, okay? Acid, base, or neutral? Let's see. Do we hear anybody? Looks like we got some guesses for acid. All right, let's see.
Oh, acid. Yep,
Oh,
acid.
nice. Who guessed acid?
I wonder.
I don't know. We'll see later. We'll see later. All right. So this is what we've got right now. We know that our neutral is this one, which is our, so let's label them really quickly. So that's our neutral, which is our water. This is our soda. Or where's our baking soda, Vivi Rose?
Baking soda.
It's the blue, right? And then our lemon juice is the pink.
Lemon juice.
All right, you want to put them over here? And that was ammonia. All right.
Which one is it?
That one.
Okay.
And what was that one over there? Do you remember?
It's that.
And that's why we should label them as we go, right? That's our laundry detergent. That's our laundry detergent, the board.
That's right.
All right, and then this is soda, which I'll have to make a different one for. So do you want to line them up in order of pH? Can you line those up in order of pH, Vivi Rose?
Yes.
Put it on the big screen. Good, that's the soda right there. Okay.
Then here.
Okay, there we go.
And then the neutral.
So there's our water, right? We'll move this out of the way.
That one's like second to last.
Okay.
This one's right next to neutral.
All right.
This one is the strongest base.
That's our strongest base. And we have some other things here to try. We haven't been able to do it just yet, but just like you guys at home, we're probably going to play a little bit more. We got plenty of extra indicator. We got plenty of extra water, and we'll see what other colors we can come up with today. So what I would love to do is take questions from you guys, because basically, what surprised you here? Did anybody, basically, yeah, I know. Did anybody get surprised by something that they saw?
Oh, I did.
You were surprised?
Soda.
Soda was a surprise.
I thought it would be like a teal blue.
You thought it would be a teal, so you thought that soda would be basic and not acidic.
Yep.
Did anybody else out there think that? It's very interesting to think about how all of these things that we just found around our house have a different pH. And one thing that I want to touch on with you guys is that pH exists in our natural systems too, which is why we test for it with our EarthEcho Water Challenge, because it's a test of whether our water bodies are healthy. Just like the pH of our blood is a test of whether we're healthy, pH is a test of whether our water bodies are healthy. Because if you have things like ocean acidification or pollution, or even if there's a dead zone in your area, it can change the pH of the water. And Vivi Rose and I have been experimenting with some shells and some stuff that we found when we were at the beach before, and looking at what acids can do to that. Why don't you sit it right here so people can see? And so you can see there, we've got this is a sand dollar that we found, and it looked great yesterday. And now, if you can see in some places, it is, oh, it's falling apart on us. So we put this in vinegar just overnight, and it completely dissolved parts of this sand dollar. Ooh, it all fell apart. This is a shell called a lettered olive, and it's hard to see, but we can actually feel the parts of the shell, coming off. And if you look, this is another fun science project if you want to do it at home. These are our Agonizer calcite crystals that are forming as the vinegar reacts with the calcium carbonate on the shell. So there are lots of different, and we've got that going on with this shell and with this clam shell that we were doing this experiment on. So if you were an organism living in any of these shells, you wouldn't make it if the pH was the same as vinegar, which is actually right around the same as this this lemon juice, the vinegar that we were using. So if it was an acid, that was this strong, it would kill things. So we wanted to make sure that you guys know you can learn a little bit more about ocean acidification through EarthEcho Expedition Shell Shocked. You can find that at www.earthecho.org. You can also subscribe to our YouTube channel and find out more about the different live virtual events that we hold to talk about things like ocean acidification and pollution. We also have a lot of different events about plastics pollution, which can also change pH, as can, like we said, dead zones. And we have a whole expedition called EarthEcho Expedition into the Dead Zone, which also talks a little bit about how oxygen and pH can cause changes, big changes in ecosystems like the Chesapeake Bay and the Mississippi River. So were there any surprises out there? Let's see, is lemon a base? I've got a few questions coming in. If soda is an acid, does that mean it can hurt our bodies? That is a great question. And first I would advise that we ask a dentist, because that's the first place that the acid tends to hit us. But actually our digestive system has a lot of acids in it. So yeah, our saliva, and we have hydrochloric acid in our stomachs to help us break down food. So, but what happens to be a problem is when that acid gets into the wrong place. It can certainly cause problems if you have too much acid or if the acid gets into the wrong place. So it doesn't hurt us to drink this as long as it stays in our digestive system where we can process acids appropriately. Now, lemon juice, also something that we can eat, but there are plenty of acids that are much stronger that your body is not capable of the cells in your body will not be able to tolerate, even in your digestive system. So you have to be really careful about acids, but there are lots of acids that make our food taste really awesome. So let's see.
Like lemon juice.
Yeah.
If you put it
like
on
lemon
salmon,
juice.
then it's awesome.
And Eden asked, was lemon juice a base? What do you think?
No, it's an acid.
Right. So we've got neutral.
And it's in a book.
Weaker acid. We'll share that later. Weaker acid, stronger acid, weaker base, kind of moderate base, and stronger base. So that's kind of the rainbow that we can make. And we can make even more of a rainbow, like I said. So do we have any other questions? So we hope you've had fun today exploring pH with us. We want to wrap this up at 12:30, but we're happy to take more questions if you put them in the comments. And we are excited to keep doing our snack size science on Wednesdays and Fridays every week in April. So we're really excited to take the time to do science at home while we're all at home learning virtually. So next week on Wednesday, we'll have Casey back again, and she's going to be doing her snack size science on Wednesday is about beaks and biodiversity. So we encourage everybody to tune in for beaks and biodiversity. Again, make sure you subscribe. That way you'll know when we're going live. And
we'll be back next Friday talking about backyard biodiversity.
Yeah, so we're going to do some backyard biodiversity stuff on Friday with Vivi, Rose, and I. And like I said, be sure to subscribe. Check out our resources at www.earthecho.org. And if you guys liked what you saw today, please don't hesitate to go to donate a little bit of money to help us keep these programs going forward at www.earthecho.org/donate.
Thank you so much for doing snack size science with us today.
And from all of us here at EarthEcho, keep exploring.
We can't wait to science with you again next week. But in the meantime, why do chemists think it's easy to work with ammonia?
I don't know, Vivi Rose. Why do chemists think it's easy to work with ammonia?
Because it's pretty basic stuff.
Nicely done, nicely done. Thanks, everybody.